fine. Blame it on me. Alright, so the integral from 9 to 23, e of t dt, whatever endpoint method we're using here, 7,730. Now, apparently I was not going full brain because when I set this up, and I remember working this out at like the place where I get my oil change, I wrote 2 times 624, and 2 times 918, and 2 times 918. How many of you guys just factored out that 2 from the beginning and had 2 times like all the stuff? Perfect. Now this is the kind of thing that you get to do when you have a uniform distribution, a uniform partition where it's equal intervals. That's the only thing we've dealt with so far. More is coming. Part D, 6,770 people. What? In Part D, 6,770 people. Aaron, you're taking out your homework, right? All right.
Wait,
in E, I just want some. What?
I got 6,710.
You got 6,710.
Yeah.
And everybody else has 6,710. Carmen, you have 6,710. Well, as long as Carmen's got 6,710 people. All right, we'll rescan that later, shall we? All right, so in Part E, all I need to know is why you think they're different, right? You're using different methods. If you're going to use a different method, you're probably going to get a different estimate. All right, Part F, the integral from 9 to 21. Now we're using a different method. We're using a different partitioning. And if all goes well, 7,128 students. Okay, good. Oh, was Part F midpoint? Part F the midpoint method?
Yes.
Okay.
Yes.
Right, now, I don't know about you guys, but especially when I'm working with the AB students and like the older I get, I need to like draw my little number line on the side. And I'm thinking I'm going to go from 9 to 21 and I need to partition into subintervals of length 4 and I'm going to use the midpoint. I'm just putting those numbers on there as a guide for me. You certainly don't have to do that, but it may not be a bad idea. All right, in Part G, now I think I switched the question, right? Is this where I started asking about the number of people that are leaving?
Yeah.
And is it okay, like, if you're leaving, now it's a different rate function that I'm going to look at. And if I'm doing from 13 to 21, it looks like maybe trapezoid method here. Let me lower this so you guys can see trapezoid method. According to my calculations, 5,493. Okay, and smarter way to do that? It's a smarter way to figure out the sum. What are the legal things you could do to make life so much easier? Steven's doing ninja moves in the back. He's trying to help.
Bro,
David, smarter things you could do.
we could just add up all the bases because what has it times 2 equals 1.
All right. You're doing 1/2 sum of the bases times the height. The 1/2 times 2 is 1. So that's like a thing for sure. Another thing that you can do for sure that would make your life so much better, Palamon? Do you see anything else really clever you could do here?
Oh, just so times the 1 and also times 1/2 just cancel out.
Oh my God, I could not have said that better myself, even though I said exactly that 30 seconds before. I know you weren't listening. The 1/2 times 2 is 1, but I've got L of 13 plus L of 15.
Oh.
I've got L of 15 and L of 17. Palamon, redeem yourself here.
Multiply the one that comes twice times 2.
Right, and so like the last base here and the first base here are the same. Last base, first base are the same. The only ones that you don't double are the very first base and the very last base. Pretty good? All right. H, number of people in the park at time t equals 17. Now here's where you've got to get clever. You've got to think, well, how many people are in the park? I'm going to take the number of people that came into the park, total, and I'm going to subtract off from this the number of people that have left the park, total. Even just getting that set up is already going to be worth some points here. And if all goes well, 4,484 people. Everybody okay with the number here? All right, in Part I, this is the one now we're looking at admissions. Now I always love it when like folks are like, oh, I'm going to do 15 times the number of people that go from 9 to 23, and then I'm going to add on 11 times the number of people that came in from 17 to 23. So you're like penalizing folks who come in late and like, oh, you're going to pay twice. Right, the people that come in between 9 and 17 pay $15 a person, so I multiply by 15. The people that come in between 17 and 23 I multiply by 11, because they come in at a discounted rate, because they're not going to be at the park for nearly as much time. And J's. I'm curious, how many of you guys honestly get that one right?
What's that?
I don't even think I asked for an answer on this one. I just asked for a setup.
Oh,
Oh,
yeah, it's for the
just for the setup?
Yeah, we did.
Did it say just for the setup?
No.
No, it shows your calculation.
Approximately how many? Oh my god.
103, 850.
103, 850? I'll figure it out later.
Oh, it doesn't matter, you can ask it for it.
Oh, so awkward. Alright, Jay, you filled in all of your table with all of these differences. Right, you know how to subtract. I hope.
Hold on.
Or else we have much bigger problems.
What do you
Okay.
mean?
Oh, I got them all.
Okay. Now in part K it says, during which 2-hour interval is the rate at which people are entering the park equal to the rate that people are leaving the park? Where would you look for this? Where is the rate that people are entering the park equal to the rate that people are leaving the park? Where and why? Just one person? That's a little scary for me. 2 people? Look at your data. There's a reason why I asked you to do this easy question first. Celeste, what do you say?
The rate would be equal when, like, if you subtracted 2 rates, it equals 0.
Right, the 2 rates are equal. Is there ever going to be a time where I'm going to subtract the 2 rates and get 0 for an answer?
Yes.
Where? Where do you look for that, Myra? Where am I going to get 0 as a difference? Between 15 and 17. Now I see like at 15 the difference is 228, at 17 the difference is going to be negative 381. And you're saying there has to be a time where the difference is equal to 0 because? Because of the IDT. Okay, we're switching from positive to negative. There has to be a place where that difference is going to be equal to 0. All the friends are okay? Alright, if you can put that in the middle of the table, I will pick it up. This is the final grade for the second 6 weeks. Please make sure your name is on it.
Did we tear it out because we used the graph for J?
Do you tear it out?
Tear up the chart.
Yeah, if you could do it without tearing the paper in half, that would be absolutely fabulous. So like carefully remove. Excellent, Giselle, for getting better at this. David, you look like you need to like get up and walk around. Can you like pick up everybody's homework assignment? Sure. All right, so let's do this. I'm curious if I have any slightly stressed out seniors in the room. Okay, do I have any like way stressed out seniors? Your hair is falling out. You're not getting enough sleep at night. Okay, not that many. Well, that's good. Because it's usually about this time of year where you're like, why God, why? Senior year is supposed to be like my favorite time of favorite year, and it's just not. But I'm glad to see that you guys are all doing well. Because I was going to say, if you're really stressed out, then I was going to make sure to like lighten up on the homework. But if you guys are fine, you got this under control. No, that's
I had to
you're
go
doing
to
enough.
sleep at 6 yesterday because I had report
And
and
then that's what I'll get out.
Aaron, do me a favor.
You have to make sure you're not hiding below that sword.
Oh, it's okay. Then can we at least take out like student packet and all the other things? Yeah, there you go. I'm gonna win on something here. All right, so we're in the middle of studying properties of definite integrals, and yesterday, one of the properties of definite integrals that we had says that it's legal to do this. It says it's legal to basically split up my integral. If I'm finding the integral of a sum, it's equal to the sum of the integrals. Just leave it on my desk. Right, we're saying it's a property. Property means that this is true all of the time. Are we okay? What other properties do we have from yesterday that you guys remember? Go look them up. Other legal things that you can do. Other legal things that you get to do with the definite integral. One person, maybe 2 people, 2 people, 3 people. David, one legal thing that you remember.
The definite integral is set to s from SV equals negative definite integral.
Oh, okay, the integral from a to b of f of x dx is equal to the negative of the integral from b to a of f of x dx. Nice. That's another legal one. There's other legal ones that I'm really interested in. Other legal things that you get to do all the time. There are some that involve constants. I'm really interested in the one with the constants. Carmen.
The one that's like k times the definite integral.
Okay, it's the one that starts off looking like this. The definite integral of k times f of x dx. There's something you can do with the constant.
And then
Right, we can take that constant out in front, and you can say k times the integral from a to b of f of x dx. You've got to be careful though. This is only true if k is constant. Okay, anybody else remember any other important properties? Stephen?
The definite integral of k over x to the dx. Wait, what's that?
Hold on,
Wait,
I think you're going into Google land here.
Wait.
The integral from a to b of a constant.
Oh,
This is the one that kept catching you guys by surprise yesterday. If you're integrating a constant,
yeah.
think about what happens when you integrate a constant. I'm asking you for area under a line. You're making a rectangle. There's a formula that you just need to know.
k times
K times
b minus a.
K times b minus a. Now there are some other properties like the integral from negative a to a of f of x dx. And you guys are going to tell me that the integral from negative a to a of f of x dx is equal to
2 times.
If the integral.
Okay, I definitely set you guys up to fail there because David's already like, oh, it's this one. It's 2 times the integral from 0 to a of f of x dx. And that's only true if f is even. Okay, even we're thinking y-axis symmetry. If, for example, you're doing the integral from negative a to a of f of x dx and you get 0, that's always true if f is
Odd.
an odd function. Okay? Unless you know something about the function f. Unless you know f is even, you can't do this. Unless you know f is odd, you can't do this. There are some other properties that I want us to explore as well. And just so that we're on the same page here, when I say property, I mean something that you know to be true all the time. For example, let's see how well you guys are with identifying properties. Okay. True or false? If two numbers multiply to give me 0, then one of the two has to be equal to 0. Let me say that again. I'll speak slower and louder. That always works. If you multiply two numbers together and get 0 for an answer, one of the two numbers has to be 0.
Yeah.
Is this true or false?
True. True.
If you're multiplying two numbers together and getting 0 for an answer, one of the numbers has to be 0.
How do you get to 0?
Oh, I think it's in
The answer is,
True.
this is true. It's the thing you do all the time. Like if you factor a polynomial, right? You're like, I have two factors. When I multiply together, they are equal to 0. One of the two things is equal to 0. All right, here's another one. In multiplication, when I multiply two numbers together, the answer gets bigger. Now, does this work sometimes?
Yeah.
Right? Like you take two numbers together, you multiply them, and the answer gets bigger, right? In order to say false, all I need is one counterexample, one instance where this doesn't work. What if you multiply by, I heard it by a negative, other things that you can multiply by? Fractions, I want to be specific.
Numbers less than 1.
Numbers less than 1. Right? When you multiply by a number less than 1, your result actually gets smaller, not bigger. So that's not a property, okay? So some of the things that you guys are going to look at right now are going to be properties. Some of them are not going to be properties. And remember, to say something's not a property, you just need it to be false one time. Pretty good? All right, so I want to give you guys a couple minutes and just do a quick skim Which of these do you know to be properties? Which ones do you just know with confidence they're properties? We'll talk in 3 minutes.
Some of the property.
Two's true. Four is true. Six is false.
Stephen, are the friends at home able to watch, see all the properties on the sideboard?
Yes.
Thanks, sir.
They are now.
No, he's good at what he does.
Sure.
He's really good, right, Carmen?
I think so, no?
He's really good at what he does.
Definitely.
what?
He's really good at what he does. Camera.
Class. Class.
Thank you.
Oh wait.
Six is false.
I don't,
It has to be four. They have to go three, and then two. That's why. Okay, the integral of x is from A to C, right? It'll be plus b to c. Six. Add.
Wait, those the one that comes with the line.
Right.
There are more extra parts.
I mean, any even function is symmetrical on the line.
Nowhere near the middle. Sorry.
You're right.
It's in the middle.
Yeah. It'll be A, B, C.
All right, let's get some hands on this. Don't call it out. Don't call it out. I want to get some hands on this. Give me a property that you know is true. A property that must be true. You guys are just having all these great conversations. There's all sorts of thoughts here. Giselle, give me one that you know to be true. Property number 2 has to be true because you've got an even function, right? I also saw you look over here. I shouldn't have given these two guys away. I think I get so excited about all the properties. I forgot that those were like on there. So this guy here is actually a property for sure. If you need to think about this, draw some sort of an even function, pick symmetric limits, and it is going to absolutely be true that the area from negative a to a is equal to double the area from 0 to a. Just, even if I hadn't listed it over there, is everybody okay? This one has to be true. Give me another one that has to be true. Another one that has to be true. Myra. Statement number 4 has to be true. Bad planning on my part. I gave it away. You've got an odd function, something maybe that looks like that. Now the key with both of these, with the odd and the even functions, is the idea that you have symmetric limits. These are balanced limits. However far you go to the right, you go that far to the left, which means that if this guy over here is negative, that guy over there is positive, that's a property, for sure. Incoming. See, mean girl, right there. Nobody gets the candy now. All right, any other properties that you know for sure, Polymon?
Statement 6.
Statement 6. How many guys want statement 6 is true? Statement 6, Polymon, give me a good argument why statement 6 has to be true.
Well,
Actually,
since
yeah,
A is less than C and C is less than D. If
Yeah.
you subtract from A to B, if you subtract from C to B, from A to B, the value has to be
Okay, one more time.
You said.
I don't think I said it.
A is less than C is less than B. The integral from A to C is going to be the integral from A to B. Subtract off from that the integral from C to B. How many guys actually had that as true? Okay. Now, but I also heard some folks arguing that that like maybe isn't true. When in doubt, draw yourself a little function. Here's f of x. Here's A. Here's B. C is given to you as having to be in the middle. The guy on the left says the area from A to C. There's the area from A to C. This guy over here says find the area from A to B. and then knock out or subtract off the area from C to B. We're okay, that's property? Okay? Another property. Anybody else see any other properties? Stephen, what other property?
The first one.
The first one you think is a property. What other thoughts are there? Is everybody going on with the first one, the property? Not sure? Okay. If you're not sure, you could draw a picture. Now, honestly, like I'm not really sure what picture I would draw here. You could also check it on your calculator. And so I want to check it on the calculator. So let's check that one on the calculator. All right, so
It's great, please, check.
Wow, you cannot read.
I thought the phone this morning.
It says much.
all right. Okay, so we've got some like calculator thievery happening. Is that what's going on?
Yes.
No, more like a literary.
Yeah.
More like illiteracy?
That's caused by literacy.
Okay. Why?
Let's go back. What?
Why is it not letting me duplicate? No, no, it won't let me duplicate.
Isn't that meant to be mine?
We could connect.
Yes, I'm connected. I meant to test it this morning and I didn't. It is connected. It was connected. Did I get some? Oh, Mr. Link is gonna get in trouble. The next 3 questions he asks me, I'm gonna give him wrong answers.
What if it's a test?
That's like a legit question.
Well,
What if it's a question about like something he's gonna teach the A, B kids?
you should have thought about that.
Oh.
Thought about that before you set me up. Oh, there it is. Okay, this is not how I saw spending this time. And this is 100% my fault.
Mayra, I did it on my paper.
Alright, not sure what's happening over there with the ladies. Celeste, you're gonna be gone 4 days next week, huh? Okay, just checking. Alright, so here's what I want to do.
Let me know that.
Actually, yeah, that means if someone else is missing, y'all can join that table, one of y'all can join this table.
Or you could not.
Alright, let's,
Oh, yeah.
look, guys,
Okay, shh.
thank you very much. So on your calculator, let's see if this is true. So the property says that if I take the integral of the product of a function, I'm not going to do this for you, get your calculators out. I need the product of 2 functions. So give me 2 functions.
X squared and
5x.
cubed.
No.
How about 5x and something interesting?
17.
3x.
Oh my god, how about like sine of x?
No,
You guys don't know interesting things, do you?
they don't.
No.
I'm integrating with respect to x, now I need limits. Let's go from like, I don't know, like 0 to 2. Okay?
Actually, 1 to.
So if I integrate the function 5x times sine of x from 0 to 2, I'm getting 8.707?
Yeah.
Anybody else getting 8.707? Okay.
8.7. Yeah.
Or 8.708?
Yeah.
Right, I want to test this against, right, integrating from 0 to 2, 5x with respect to x.
Error.
Try that again. Menu, calc, numerical integral, from 0 to 2, 5x with respect to x. And multiply that with the integral from 0 to 2, sine of x with respect to x. If this actually was a property,
False.
right? If it was a property, then what I would get is the exact same numerical values. Since I'm not getting the exact same numerical values here, what I can say is like there might be some times where it works, but at least in this one instance, so we're okay with the idea that like this doesn't work, I'm not getting the same numerical value. So these two aren't equal to each other. So your conclusion?
False.
It's false. It's not a property. You might find some cases where it does work, But at least in this one time, it doesn't work, not a property. And if it's not a property, that means you can't use it. Okay, that didn't go quite as smoothly as I was hoping for. Okay, now here's the thing. If statement number 1 is not a property, statement number 5, right, trust your instincts here. Statement number 5 is also probably not a property. Generally in mathematics, if there are properties in the world of multiplication, there are similar properties for division. Think like logarithms. There are some things you can do like the log of a product. You can split it apart. You can also split apart the log of a quotient. Now I haven't heard any conversations about statement number 3, and it looks like you guys maybe haven't had a chance to really think about statement number 3. So see what you can do with statement 3. We'll talk in a bit. Lewis, everything okay?
Oh, yeah.
So Lewis, is this both assignments?
Yes,
Okay.
that's like,
Thank you. If you think it's a property, get me some sort of a sketch that you could use as your evidence.
like with, that's true. Because
I
with,
think it's true.
Yeah, it'll be consistent in paper. Even
It's always above it, right? That's the best. No, geometric is always above it.
Okay, and some good sketches. You know that f of x, if f of x is the black graph here, g of x is always greater than or equal to do that. So like maybe it even does something crazy like that. If a and b are like here and here,
Oh, yeah.
that's the area underneath f of x.
But the intervals are not.
That's the area underneath g of x. That looks to me like this is a true statement, right? That g of x has more area and that g of x will always have more area. Is everybody okay with this? Did anybody come up with a counterexample or a situation where it doesn't work? Palamon, what do you have?
Like Mara was saying, it's okay. It was 5 of x compared to e of x. E of x will be comparably bigger, but during the small intervals, it's not going to be. In certain intervals, it won't be bigger.
Say that one more time.
He was comparing 5x to the function e of x.
Okay, so the function like y equals 5x,
And he has a function y equals e of x.
y equals e to the x.
But
From one interval to the other, it won't be right.
Okay, but here's the thing. The statement here says that if f of x is less than or equal to g of x on that interval.
Meaning that g of x
So
is
like
bigger.
if 5x is the smaller function on the entire interval from like here's like a, here's b. If 5x is the smaller function, then doesn't 5x have to contain less area than e to the x? Right, I think what was happening in your example, maybe you were thinking about a place where like e to the x is taller, right? Where like there's like a place where they switch. The statement here is that f of x is always less than or equal to g of x on that interval. We're okay?
Yeah.
Alright, we've gone as far as I wanted to go with like exploring these properties. What I want you guys to be able to do is actually use the properties. So let's look at the homework for this weekend. It's assignment number 78. There's a grand total of 11 multiple choice questions.
You did 7 times, right?
And so ugly, so unfortunate. Oh, I didn't catch that.
What?
The problems that you're going to do on page 9 are the back of the problems that you're going to wind up doing on page 10 eventually. So bad planning on my part, I'll fix that later. Here's what I want to do. I want to give you guys some time to knock out about half of these. So we've got 4, we've got 7, we've got 11. You guys can blame Lewis on this. He showed up at just absolutely the wrong time. Everybody gets some time to work with a partner that you are not currently sitting with. Go, make it happen, make it happen. The longer this takes, the less time you get in class to work on this.
Give you each of us.
Mario.
Oh, dang it.
Come over here, baby.
Wait, none of the four of you moved.
Me and Carmen.
Celeste is coming to you. Okay, that means Andrew, Steven, and Lewis are looking around at each other like, uh-oh. Come on, come on, come on.
Somebody
All
got
right, you've got partners. You've got partners. David moved. Ile moved. All right. Eeny, meeny, miny, mo. Steven, you got the camera, and you might want to fix your shirt because we just saw your boxers. All right. Yes, you're wearing boxers. I have proof now. All right. You have a couple minutes with your partner problems. 1, 4, and 10. Show me what you can do with 1, 4, and 10.
It's -5. 2.
Yeah.
So this has to be positive. So what?
It means that.
So from
And then this is before.
2 to 5.
Yep.
So when we were doing the last one, we were using E of x and 5x
Yep.
on the interval 0 to 2, and we got 2 to 5.
Okay, hold on. Did you graph easy x and 5x on the wizard kid? That's the problem. I bet if you actually look at the graph, what you're going to see is there's going to be a place where they switch.
Okay.
Oh, you subtracted
And if there's a place where they switch, it's why you can't.
that.
You weren't actually testing statement per unit.
They're both negative. You're adding negative to negative.
Okay. Friends over here, how are you doing?
But you're adding.
So it's 1, 4, and 10.
You're doing negative.
1, 4, and 10.
Negative.
1, 4, and 10.
Like you're adding. Oh, you're saying this property.
See? You felt good about that? Good. All right, what do we get for number 1?
Is it A?
B, right?
It's not A. Yes, it is B.
No.
So what was the mistake there?
Oh, they forgot to
You
just
subtract.
They forgot to
They forget
You subtract.
You're not supposed to. It's 2 times.
So the interval from -5 to 2 gives you -17.
Because of this function. This. Not that one. It's not that one.
I think I tricked you with the second.
It's not that, because look, I didn't flip them. It's only going backwards. You didn't flip the value.
Here you're going from -5 to 2. Here you're going from 5 to 2. So if the integral from 5 to 2 is -4,
Stop this interval where
you need to think about doing the interval from 2 to 5. Okay? What did you guys get from this one?
it'd be -17 minus 2.
Excellent. So I didn't trick you with that.
I mean, the way you did it.
What did you guys get for
Well, I
your?
mean, that's hard.
Yeah.
So,
The longer you get the right answer.
Feel good about me? Okay, so the issue is, I'm telling you the integral from 5 to 2 is equal to -4. So on the number line, here's 5, here's 2. If the integral from 5 to 2 is -4, what you really need to be thinking about is what's the area from 2 to 5?
Yeah, one of them has to
The area from 2 to 5. Right, we're gonna switch the limits of integration.
Good
Switch
feelings,
the sign of the
it
area.
should be plus 2. I feel like this is
Okay, nice.
it doesn't matter.
And for all the friends out there that Steven's not talking to right now, hopefully you picked B, not A. And the trick in number 1 is the integral. It says the integral from 5 to 2 is -4. But what I really need to be thinking about is not the area from 5 to 2, but the area from 2 to 5. The area from 2 to 5 would have to be +4. But I'm sure Stephen here spent some time explaining all these thoughts to you on the other side of the camera. Keep going.
So for number 4, you should have gotten G.
Okay,
I don't really know how to explain it, but
is a positive number.
Yeah, negative way would work.
So like 5, but since it's below the impact, it's still gonna have to be negative. All right, friends, so if all went well, everybody has B for number 1. And for number 4, the answer is
G.
G. G. All right. Now, did anybody actually get to number 10? Okay, I need you to switch partners. Find somebody that you haven't worked with yet. Somebody new is coming over here.
I just saw him since back and forth and
No, crap, we all look at each other.
Give me 1 second. All right. All right, Aaron, I guess you're over here. All right, here's the 2 that you're going to work with your new partner. I'm really interested to see what you can do with problem number 10 and then with problem number 8. 10 first, then 8. We'll chat in a couple minutes. Okay, and Holloman will finish that conversation. Alright, A1 and A2 are positive numbers, so like some number like 5, 8. But you're below the x-axis. So that's a negative. So what's the area from -4 to 1? So you could say it's just like A1 minus A2. And then the area from -1 to -4 is the opposite of A1, so negative A1. So A1 minus A2 is what this first integral is equal to. This next one is going to be negative 2 times whatever this is. You got that?
yeah, it cancels out the original and then add it to an extra negative.
Yep. How are we doing? That's F. Okay, so what clever thoughts do you have so far?
See if that makes sense. I don't think it does.
Okay, so the folks at home. So Aaron's basically saying, okay, let me look at these 3 different areas,
But they're all equal to.
and they're all equal. They're all equal to like negative.
No, they're all equal to 2.
Oh, they're all equal to 2, but A and C both have an area of -2. B is an area of +2. And then you're saying you're just adding 1, so let me add 1 to each of those values. And actually, that's the mistake.
Yeah, I was like, I knew that. I caught it like halfway through.
Yeah. What I would encourage you to think about is there's 2 integral properties that you're going to need here. There's one integral property that says you can distribute that integral to both parts. So you can find the integral from -3 to 3 of f of x plus the integral from -3 to 3 of 1.
I mean, thanks.
Okay.
Let's see what you can do with that. Okay, friends back here, how are we doing?
-2, right?
Let's do.
Because it's negative area. Below the x-axis, so that's negative. Like positive term would be -2. So this one. And then in the +1.
I think it's wrong, like I
On problem number 10, I'll tell you it is not F. It's not F. Not 12.
It's H.
Is it G?
It's H.
These are all the letter choices, yeah. Alright, because we're all still babes in the woods here.
Hold on.
Okay, for anybody who's needing a little bit of a nudge, rather than, oops. Yeah, I know. Okay. Alright, on number 10, rather than working with this expression, how about using a property? Oh, I don't know, like this guy here that says I can take that definite integral and distribute it to both parts. This part over here, the integral from -3 to 3 of f of x dx just means take all these areas and add them up, but keep in mind their signs. So the area for A is -2, +2, -2. Total area from -3 to 3 is
Or -2, yeah.
-2. It's this guy over here that I think people are making mistakes with. The area from -3 to 3 underneath the curve 1, right? That's a line, that's a horizontal line with a height of 1. You're going from -3 all the way over to +3, so that is a length of 6, -2 plus 6. It's going to be 4. That's why it's going to be G. Okay? Alright. One more that I want you guys to do on your own. No need to move at all. Problem number 8. Be careful. Are we about ready to lock in an answer? Alright, let's just go one statement at a time. How many guys think that statement number 1 is a property? Thank God, we were just talking about this one, right? Not a property. Statement number 2.
Yeah.
Statement number 2, this one works? How about statement number 3?
No.
Yes.
Yeah, it does.
No.
Yes,
Yes,
it does. F of
Read
x
it.
is greater
Read
than
F of
zero.
Lewis, why is statement 3 true?
Read F.
Since f of x
You
is
have to be
greater
on
than
the whole
0,
thing.
it's the same thing as f
If
of
6
x
is greater than 0, then
They
f is
caught
greater
you.
than
They
f.
told you in the beginning that f of x is greater than or equal to 0. F of x is always positive. If f of x is always positive, what happens when you take the absolute value of f of x? Nothing. These are equal in that particular case, so the correct answer would have to be J.
He said be careful. I was like,
Right? If I take away this statement over here, then it's a false statement because it's not true all the time. Everybody okay? Alright, one last rotation. We're not working on homework anymore. Anything that didn't just get finished in class is tonight's homework. You guys have like 6 or 7 questions left. It's not going to take that long. I do want you to go back to the student packet, please. And working with whoever you have the pleasure of working with right now, focus on problems 1, 2, 3, and 4. Now, the instructions here are a little bit different than the way we played this yesterday. I've given you some area information at the top, and I want you to decide what the value of the integral is, or tell me that it's not possible to figure out what that area is. Right? Either you have properties that are going to help you get to the area, or there are no properties that are going to help you get to the area. Once you've got all of those under control, call me on over and I'll move you on to the harder ones.
Because remember this equal right here.
Okay.
Now I can remember this. Yeah, K times everywhere.
Which number?
I mean, I'm doing them in whatever order.
Well, you can say K.
You don't take you just move it to the front. So you just move it to the front. 0 is 10, so you just do K times 10, which is 10K. That's how we do it. That's how we do math.
Put random numbers together and hope it works out.
Yeah. This and this. Oh, yeah, here. What would you do that? 10 minus 3 halves. 5 halves? 10 minus 5 halves. 10 minus.
What would be
No, you don't add them because it's taking away. Alright, you said go. So that'd be 18 halves. So I was doing.
You're feeling good about 1 through 4,
You
Palmetto?
can just turn 5 over 2 into 2.5 and then 2.5 and
It's
it's going to be
37
7.5.
the same thing.
-2, -1.
It's just the flips of this.
Yeah.
No.
It's not negative value. Remember when it's a negative, it's just gonna it equals
No.
the same. When it's the
No, it's just opposite. It's opposite. If you
Oh,
flip
right,
two
right.
values, they're opposite.
No property applies. Because F of X more than can be the same F of X as F of X.
Squared. Wouldn't it just, no, it wouldn't. It wouldn't just be 10. It wouldn't be 10 squared because it's not the whole thing.
I know once.
Yes, and the key is you actually know the areas from 0 to 8. And you know the areas from 3. That's why you want to
Would you like this?
Yep. Alright, see what you get, 6 and 8.
I think it would be like.
wouldn't we be able to move the squared to the
Okay, which ones do we feel about?
I don't know.
2, 1,
1, 2, and 3. I do not agree with you guys on number 1.
Number 1.
I do agree with you on number 2.
What about number 3?
And I do agree with you on number 3. I don't agree with you on number 4.
So we don't subtract. Oh wait, we might have flipped it.
Yep, that's the problem.
Yes. 5 halves minus 10.
Love it.
It's 5 halves.
Love it. Love it.
I don't know how. It's 5 halves minus 10.
So try 8 and then 6.
the value of
Is it 5 halves minus 10?
5 halves.
Not 5 halves.
There's not enough to minus 5 halves.
Because.
Well, it is 10 minus 5 halves. Oh, that's a 7.5 on your paper.
What did you think it was?
And that's a 7, is that a 7.5?
Oh, you thought that was
paper?
a 2.
That, thank you. Sorry, I don't think both your papers are silly. Okay, good. Try 8 and then 6.
8.
Yes, friends.
No, it's an odd function.
Did you guys agree?
Odd function is mean that.
Alright, 15 over 2 gives you a negative 4. There are no properties, right? Right now, there are no properties when it comes to world multiplication. When we hit the calculus BC part of the course, that life changes. Okay, 8 and 6. Okay, for the friends working at home, or wherever it is that you might be working, hello.
Well, that's what rotation of symmetry means.
So for all the friends on the other side of the camera, problem number 1 is 15 over 2. You found the integral from 0 to 8. You subtracted from that the area from 0 to 3. 10 minus 5 halves, 15 over 2. Problem number 2, you've got k as a constant. You can factor the constant out in front. The integral from 0 to 8 of f of x is going to be 10, so your answer here is 10k. And number 3, the integral from 2 to negative 1, you already know the information from negative 1 to 2, so flip those integrals. It introduces a negative, you get negative 4. Problem number 4, no properties exist that are going to allow you to do anything with that exponent until we get to the calculus BC part of the course. Then life changes a little bit. Yay, integration by parts. That's later. For everybody on the other end of the camera, 8 and 6. Keep going. God. Nice. God, I finally found something you can do. Hi, you guys are like early. Bye bye.
Wait, did the bell ring?
No.
I actually don't know what happened. Oh.
And that would be the bell. All right, my friends. I will see you guys later. Hope everybody is feeling good about stuff.
Yes.
All right, number 8. The answer should be 0. And number 6.
6 should be
4.
Is 4.
Okay, someone pause
Okay.
that.
The rest of the homework is to finish the multiple choice problems. Have a great weekend. Stay safe. Stay away from boys. Boys are bad.